So, আমি আগতে homogeneous catalysis বা acid base catalysis তাৰ বিষয়ে ডিসকাস কৰিছোঁ আৰু লাষ্ট ক্লাছত আমি এনজাইম কেটালাইসিস তাৰ বিষয়ে ডিসকাস কৰিছোঁ আৰু তাৰ নোটটো তোমালোকে নিশ্চয় পাইছা সো আমি সেইখিনি কথা ডিসকাস কৰিলোঁ এতিয়ালৈ এতিয়া আমাৰ আন এটা বস্তু আছে এটো হৈছে heterogeneous catalysis so we are to discuss about heterogeneous catalysis heterogeneous catalysis means heterogeneous catalysis means the catalyst may be solid and the reactants may be gas okay so that means catalyst and reactants they are in different phases so that is heterogeneous catalysis okay now heterogeneous catalysis is a surface phenomenon that means say this is a catalyst suppose this is the catalyst say this is the catalyst say now what happens is that the reactant molecules cling to the surface of the catalyst reactant molecule এনেকে সারফেসত লাগি ধৰে সারফেসত লাগি ধৰাৰ পিছত কি হ'ব দুইটাৰ মাজত ৰিয়েক্টেন্ট হয় সাপোজ দিস ইজ A দিস ইজ B okay so A molecules also cling to the surface B molecules also cling to the surface then reaction takes place as a result of the reaction product is formed and product is removed from the surface okay so clinging to the surface এই যে সারফেসত লাগি ধৰিছে তাক আমি কওঁ adsorption আৰু এই যে সারফেসৰ পৰা গুচি গ'ল এৰা খাইছে সারফেসৰ পৰা যে এৰা খাইছে that is called desorption adsorption surfaceত লাগি ধৰিছে clinging to the surface adsorption and removed from the surface desorption okay so heterogeneous catalysis takes place through adsorption therefore in chemistry adsorption is a very important topic because so many catalytic reactions are there where catalyst is a solid and reactants may be gas or liquid okay so in that case the reaction takes place through adsorption therefore adsorption is very very important topic and adsorption is a surface phenomenon adsorption to ক'ত হ'ব সারফেসতে হ'ব not inside the solidটোৰ ভিতৰত নহয় সারফেসত হ'ব adsorption therefore it is also called surface chemistry adsorption means we are talking about surface chemistry because adsorption takes place at the surface chemistry okay now see suppose there is liquid water is there say there is water here we have water okay here we have water so water molecules are there water molecules are there. These are the water molecules. You know, water molecule at this center, one water molecule at the center is surrounded by other water molecules, water molecules, and there is attraction. There is attraction. Say attraction is there, okay? Or I can write like this also, attraction is there, attraction is there, attraction is there, attraction is there, attraction is there. So as a result, the resultant attractive force on this molecule is 0. This molecule is attracted from all sides, So the resultant attractive force on this molecule is 0. But the molecule at the surface, there is no water molecule. So the molecule at the surface experience a inward pull, inward, ভিতৰৰ ফালে. So molecule at the surface experiences an inward pull. Okay, there is free valencies. So this is attracted from all sides, but there is no molecule. This is not attracted from all sides. So we say that the molecules at the surface experience inward pull, okay, inward pull, and these molecules have some free valence. That means they can combine with others. In case of solid also, suppose now say this is a solid, same thing happens here, and these are the atoms or molecules at the surface. Okay, these are the atoms or molecules at the surface. Just like this, an atom inside is surrounded by other atoms, so resultant force is nil. Okay, that means this atom does not have free valency. All valencies are satisfied. Okay, but in case of these, all valencies are not satisfied. Suppose this is a piece of carbon. This is a piece of carbon, and these are the carbon atoms. If you break here, suppose we are breaking here, then what happens? You see, this carbon now has free valency. This carbon has unsatisfied valency. We are breaking here. Similarly, this carbon has unsatisfied valency. So any atom at the surface, may have free valency. So they can combine with some other species. At the surface. Okay, so therefore here adsorption may take place. So we say that the atoms at the surface has some residual forces. The atom at the surface has some residual forces. Okay, because they can attract. They have some residual forces. Okay, so they can attract some species, attract some other molecules. So they can attract. They have some residual forces. So they can attract some molecules or some other species. Species. So they get bound to the surface atoms. Okay. Thereby, what happens is that if it has some unsatisfied valency, if these atoms have some unsatisfied valency, then its energy will be more. If the valency is satisfied, then energy will decrease. Energy will decrease. Okay? Anything, say free hydrogen atom, it has more energy. But if it is bound, say molecule, in hydrogen molecule, the two atoms are bound. So molecule has lower energy than the two separate hydrogen atoms. Okay, that means when they are bound, when the two atoms are bound by chemical bond, then energy decreases. Same is the case here. Okay, the atoms at the surface have unsatisfied valencies, so they can attract some other molecules or atoms, okay, so that the valencies get somewhat satisfied, okay, and therefore the energy of the atoms decreases. Energy of the atoms decreases. We say that surface energy of the solid decreases. Okay, the molecules which are attracted to the surface, they are retained. Molecules which are attracted to the surface, they are retained at the surface. Surface to lagi thake, they are retained at the surface. আৰু সেইবোৰ ভিতৰত নাহে, ভিতৰত সোমাই নাহে. Okay, this phenomenon is the adsorption. So we can say that the phenomenon of higher concentration of a substance on the surface of a solid is called adsorption. Mind that it is adsorption. It is adsorption. It is not absorption. Not absorption. In case of absorption হলে কি হ'ব, সারফেসত থাকিবই, ভিতৰটো সোমাই আহিব. But adsorption হলে on the surface only. Okay, example is that, say, have you seen silica gel? There is one species, silica gel indicator. That is one species there. Silica gel indicator বুলি এটা substance আছে, সেইবোৰ কিছুমান টুকুৰা থাকে. Some pieces like this. Some pieces. Okay? And they absorb moisture on the surface. আৰু তোমালোকে উঠাই কিছুমান ইনষ্ট্ৰুমেণ্টৰ ভিতৰত সৰু সৰু পেকেটত কিছুমান গুৰি পোৱা, that is nothing but silica gel. They can absorb moisture absorb কৰে সিহঁতে. Okay, so this is an example. ঠিক তেনেকৈ চাৰ্কোলৰ ওপৰত বিভিন্ন বস্তু absorb হ'ব পাৰে. So many different things. তাতে এয়াৰ absorb হ'ব পাৰে বা আন কিবা যিকোনো বহুত বস্তু absorb হ'ব পাৰে on charcoal. Okay, so many different things are there. This is adsorption. So you know that there may be two types of adsorption. One is physical adsorption, the other is chemical adsorption. Chemical adsorption. Two types of adsorptions are there. Physical adsorption and chemical adsorption. Okay. Now, you see, we have said that when a substance gets absorbed on the surface, যেতিয়া adsorption হ'ব তেতিয়া energy decrease হয়. Energy decrease হোৱা মানে it is del H is negative. Okay, energy decreases. That means energy is released. ইয়াৰ এনাৰ্জি ডিক্ৰিজ হৈছে, ইয়াৰ এনাৰ্জি ডিক্ৰিজ হৈছে মানে কি, ই এনাৰ্জি এৰি দিছে, এনাৰ্জি ইজ ৰিলিজড. চ' দিছ ইজ এক্সোথাৰ্মিক প্ৰচেছ. এডজৰ্পশ্যন ইজ এক্সোথাৰ্মিক প্ৰচেছ. আই ৰিপিট, চ' ইয়াৰ ওপৰত এডজৰ্পশ্যন হৈছে, ইয়াৰ ওপৰত এডজৰ্পশ্যন হৈছে. এডজৰ্পশ্যন হ'লে ইয়াৰ এনাৰ্জি কি হ'ব, ডিক্ৰিজ হ'ব. ছাৰ্ফেচ এনাৰ্জি ডিক্ৰিজেছ. এনাৰ্জি ডিক্ৰিজ হোৱা মানে it is releasing energy. Energy release korise. So energy releasing means adsorption is exothermic process. Our energy decreases, so del H is negative. If energy increases, del H is positive. Okay, so here del H is negative generally. Now, when one mole of a substance, okay, there are some terms. Okay, molecule which gets adsorbed, so this molecule gets adsorbed, so this is called adsorbate. Species which gets adsorbed is called adsorbate, and on which adsorption takes place is called adsorbent. This is the adsorbent. Adsorbate. Okay, so when adsorbate gets adsorbed on the adsorbent, then energy is released. Okay, when one mole adsorbate gets adsorbed, then the energy released is called enthalpy of adsorption. What is enthalpy of adsorption? Enthalpy of adsorption we can call it del H. Enthalpy of adsorption, del H. What is enthalpy of adsorption? It is the energy released when one mole of adsorbate gets adsorbed. One mole adsorption hole jimankhini energy release hobo, that is enthalpy of adsorption. So in case of physical adsorption, enthalpy of adsorption is less. Maximum it may be 40 kilojoule per mole. Maximum at best. This is minus, of course. Minus. Okay. Maximum value is 40 kilojoule per mole. But in case of chemical adsorption, enthalpy of adsorption is more, del H more. It may be up to 40 to 400 kilojoule per mole. Enthalpy of adsorption is more. Okay. Then, so there are some differences you have already studied. I think you studied about the differences in higher secondary classes. Still, I will mention some differences. Here, weak interaction between adsorbate and adsorbent. Weak interaction. That means relatively weak force of attraction. Weak interaction means weak force of attraction between adsorbate and adsorbent. And the type of force present between adsorbate and adsorbent is called van der Waals type of force. So weak van der Waals type of force exists. What is van der Waals force? Suppose this is one this is one say nitrogen molecule, this is another nitrogen molecule. Okay, so between these two molecules attractive force is very, very small. Okay, so this attractive force between two molecules, mind that not two atoms, attractive force between two molecules, that is the van der Waals type of force. Okay, there is attraction. How we say that there is attraction between these two molecules? Because normally nitrogen is gas, but it gets converted into liquid, nitrogen liquid. This is nitrogen gas, it gets converted to nitrogen liquid. So liquid hoise mane ki molecules are coming closer. Aru osort kyo aise? Molecules are coming closer. Why? Because there is attraction between the molecules. Okay, so this type of attraction force present between the two molecules is van der Waals force. So there is weak force between adsorbate and adsorbent in case of physical adsorption. And what type of attractive force exists? Van der Waals type of force exists between adsorbate and adsorbent. Here strong chemical bond is formed. Strong chemical bond is formed. And strong chemical bond is formed, so enthalpy of attraction is more, enthalpy of adsorption is more. Okay, now physical adsorption is not specific, okay, but chemical adsorption is highly specific. That means, what does it mean? That means one particular species gets adsorbed on a particular adsorbent. One particular adsorbate gets adsorbed on a particular adsorbent. But there is no specificity. That means anything can get adsorbed on any. Okay, not specific. Then physical, it is reversible. Reversible means adsorption and desorption takes place simultaneously. Adsorption and desorption take place simultaneously. So it is reversible. It is not reversible. Then here multi-layer adsorption takes place. Okay, multi-layer adsorption means, say this is the adsorbent, one layer of atoms like this, one layer of molecules or atoms, then another layer, maybe adsorbed like this. Adsorption may take place like this. But in chemical, it is mainly monolayer. It is mainly monolayer adsorption takes place. Okay. Then physical adsorption generally takes place at low temperature, but this is at higher temperature. There is, I can give you one example. Say this reaction, manufacture of ammonia by Haber's process, manufacture of ammonia by Haber's process. Here iron is used as catalyst. Okay, so on iron, say this is the iron, okay. Here nitrogen gets absorbed, hydrogen gets absorbed, then reaction takes place. Okay, this is a nitrogen, this is hydrogen. Okay, then reaction takes place. Now say at nearly temperature 770 Kelvin, at this temperature, so chemical adsorption takes place. As a result, more energy is released. Chemical adsorption, enthalpy of adsorption is more. That means more energy is released. So at this temperature, this reaction at this temperature, chemical adsorption takes place. So more energy is released. Okay, more energy is released. So nitrogen has triple bond. In N2 there is triple bond. So in order to form ammonia, this bond must be broken. And this is triple bond, very strong bond. So in order to break this bond, sufficient energy is required. And how this energy is achieved? One is due to this. Chemical adsorption takes place, so more energy is released. This energy is very much there. Ekhini energy asei. In addition to that, we are getting some extra energy. And these two energies help in breaking this bond between the two nitrogen atoms. Okay, so chemical adsorption takes place at this temperature. But if we decrease the temperature, to say 80 Kelvin, at this temperature, nitrogen is liquefied. At this temperature, we get nitrogen liquid. So at that temperature, physical adsorption takes place between nitrogen and iron. Physical adsorption takes place. Okay, because between two nitrogen molecules, van der Waals force will be there. So here van der Waals force is effective. Okay, so you see at this temperature we have liquid nitrogen. Okay, and physical adsorption takes place between iron and nitrogen. But at higher temperature, chemical adsorption takes place. Strong attractive force. So more energy is released. Okay. Well, so this is all about physical and chemical adsorption. Now, so one scientist called Freundlich he tried to explain the adsorption phenomena. And in order to do that, he gave an equation. The equation is just like this. X by m equal to k into c to the power 1 by n. Okay? He studied adsorption, and by studying adsorption, he gave an equation like this. This is an empirical relation. Meaning that this equation has not been deduced. A equation to calculate kori ulwa nai. Any DDC equation. Okay? Here x is the mass of adsorbate. Here x is the mass of adsorbate, and m is the mass of adsorbent. You can see that x gram of adsorbate getting adsorbed in m gram of adsorbent. You can think like that. Here k and n, these are constant. And c is the concentration of the adsorbate. Say adsorbate is in say solution. Say suppose we have here oxalic acid solution. That means oxalic acid is solid. So oxalic acid dissolved in water. Okay, we have oxalic acid solution. Here if you put some carbon, okay, if you put some carbon, oxalic acid gets adsorbed. Okay, so in this case C will be the concentration of the oxalic acid solution. That means here adsorption takes place in solution. Okay, the adsorbate is present in solution, and adsorbate gets adsorbed from solution. So we have concentration of the solution. But the adsorbate may be gas also. If the adsorbate is gas, so then equation will be like this. This is P. This is for gaseous adsorbate. Now here adsorption between solid and gas. Okay, so P is the pressure of the gas. Okay, for adsorption of gas on solid. This is for adsorption of gas on solid. And this is in case of solution. Okay. Now here if we take log both sides if we take log, so log x by m equal to log k plus 1 by n log c. Now if we draw a graph between log x by m log c, so y equal to mx plus c, so we will get a straight line. So the graph will be like this. Okay, the graph will be like this. We will get a straight line. Okay, we will get a straight line like this. Now here if you take the slope slope of this line, if you take this slope means y by x. If you take this slope, and you will get the value of 1 by n. Here slope equal to y by x equal to 1 by n. We can measure this, so we know this slope. Since we know this slope, we can find out the value of n. Okay, and this is of course log 3. This is of course log 3. Okay, so now what is that? Say adsorption. Say oxalic acid is adsorbed on charcoal. Oxalic acid is adsorbed on charcoal. Okay, actually here we take, in this experiment, you have to do this experiment. If normal classes are held, you have to do this experiment. Adsorption of oxalic acid on charcoal. You have to do this experiment. So how we do this experiment? We take activated charcoal. We take activated charcoal. How we get activated charcoal? We take some charcoal and heat it to higher temperature. Heat it for some time to higher temperature. Okay, higher temperature means it may be say up to 625 to, okay, we take charcoal, we heat up to say 625 to 1275 Kelvin. 625 to 1275 Kelvin. Within this temperature we heat it. Okay, then what happens is that many impurities are removed. On the charcoal, some hydrocarbons may be there, okay, or some other impurities may be there. So all these get removed. হিট কৰিলে কি হ'ব, চাৰকলখিনিক হিট কৰিলে কি হ'ব, ইয়াত যেটো কিছুমান ইম্পিউৰিটিজ থাকে, বেলেগ বেলেগ ইম্পিউৰিটিজ হ'ব পাৰে, আৰু হাইড্ৰকাৰ্বন কিছুমানো মিক্স হৈ থাকে, সেইবোৰ ৰিমুভ হয়। দে আৰ ৰিমুভড হ'লে কি হয়, ছাৰ্ফেচ এৰিয়াটো বেছি হৈ যায়, কাৰণ এইবোৰ যদি এই ইম্পিউৰিটিজবোৰ লাগি থাকে যদি ছাৰ্ফেচ এৰিয়া কম হ'ব। ওকে, আৰু যেতিয়া ইম্পিউৰিটিজ গুচি যাব তেতিয়া ছাৰ্ফেচ এৰিয়া বেছি হ'ব। Therefore, before using charcoal, we heat it just to activate. Activate means we are removing the impurities so that surface area increases. So we take activated charcoal here. Okay, we take oxalic acid solution, we take activated charcoal and stir it for some time. কিছু সময় আমি ষ্টায়াৰ কৰিব লাগে, নিয়াৰলি হাফ এন আৱাৰ ষ্টায়াৰ কৰি তাৰপিছত আমি অক্সেলিক এচিডৰ কনচেন্ট্ৰেশ্যন উলিয়াব লাগে। হাউ টু ফাইণ্ড আউট দি কনচেন্ট্ৰেশ্যন অফ অক্সেলিক এচিড? মে বি টাইট্ৰেটিং এগেইনষ্ট সোডিয়াম হাইড্ৰক্সাইড সলিউশ্যন। Okay, so before adsorption we measure the concentration of oxalic acid solution. How? By say titrating against sodium hydroxide solution. After adsorption we again measure the concentration of oxalic acid. How? Once again by titrating against the same sodium hydroxide solution. So we know the difference, so we can find out the amounts of oxalic acid being adsorbed here, and we will take a definite mass of the charcoal. So we know m is the mass of adsorbent, that is mass of charcoal here. Okay, So we will take a definite amount of the adsorbent, that is charcoal. So we know the mass of the charcoal. So we know the mass of the mass of oxalic acid adsorbed. Okay, how to do that? We know the initial concentration by titrating against sodium hydroxide solution. After adsorption, we again measure the concentration again by titrating against the same sodium hydroxide solution. So we know the difference in concentration. From that we can find out X. So we know X, we know M, we know the concentration of the solution. So we can draw this graph. If we get a straight line, then we say that Freundlich adsorption isotherm, Freundlich adsorption equation is valid. This equation is valid. If we get a straight line like this, then we say that this equation is valid. But problem is that this equation is not valid under all conditions. Okay. Next, another equation was given by Langmuir. Okay. Langmuir. Equation is also called isotherm because same temperature. Iso means same, therm means temperature. Okay. So Langmuir also will give another equation. Now এই ইকুয়েশনটো এবাৰ ডিৰাইভ কৰিছে কিন্তু ডিফাৰেন্স বিটুইন Freundlich and Langmuir. Freundlich did not derive this equation, but Langmuir derived one equation. Okay. Now he first considered adsorption of gas on solid. He considered adsorption of gas on solid. He took some assumptions. Langmuir used some assumptions. What are those assumptions? Number one assumption is that the adsorbed gas behaves ideally. What is ideal gas? You remember ideal gas? What is ideal gas? If there is no attraction or repulsion between the molecules. Okay? If there is no attraction or repulsion between the molecules, then it is an ideal gas. That means no attractive or repulsive forces between the molecules of the gas. So he absorbed ideal behavior. Okay. Second thing he considered is that the surface of the solid, is homogeneous. That means if this is the surface of, if this is the catalyst, this surface is exactly same, no difference at each point. Property of the surface is same. So surface is homogeneous. That means at each point property of the surface is the same. This surface is homogeneous. Okay. Surface is homogeneous. Then he considered that the surface has a fixed number of number of adsorption sites. Adsorption sites. Okay, there is a definite number of adsorption sites on the surface. There is a definite number of adsorption site, and each site has the same attraction for the gas molecules. So basically, we have said that this surface is homogeneous. Surface is homogeneous means each point has the same attraction power. Surface is homogeneous means each point has the same attraction power, and there is a definite number of adsorption site. Okay. Third thing is that each adsorption site can absorb only one molecule. That means only monolayer adsorption can take place. Only monolayer adsorption can take place. Okay, so Langmuir considered only monolayer adsorption. That means only one layer. Okay, so number four is that so equilibrium exists between condensation and evaporation of gas molecules. Okay, it means that suppose this is the gas molecule. Okay, this is the gas molecule, and this is the catalyst. This is the surface. Okay, this is solid. This is solid surface. So adsorption takes place. Okay, as a result of adsorption, we get this. So adsorption takes place. That means condensation is taking place. At the same time, desorption is also taking place. This is adsorption, and this is desorption. And equilibrium exists. That means rate of adsorption is equal to rate of desorption. তাৰমানে 1 সেকেন্ডত যিমানটা এডজৰ্ব হৈছে সেই 1 সেকেন্ডত সিমানটা ডিজৰ্পশ্যনো হৈছে. So equilibrium exists. Okay, equilibrium exists. Now initially what happens? So what does this equilibrium actually mean? এই ইকুইলিব্ৰিয়ামটোৱে আচলতে কি বুজাইছে? So initially to yet adsorption হোৱা নাছিল. Okay, this is the solid surface. Initially yet adsorption হোৱা নাই. Okay, initially adsorption হোৱা নাই. So there is more adsorption site. গতিকে ইয়াত adsorption site বহুত আছে. গতিকে this is the solid. Initially no adsorption has taken place. So more adsorption sites are there. As the number of adsorption site is more, So rate of adsorption will be more. Rate of adsorption will be more. But as adsorption takes place, number of adsorption sites remaining also decreases. Initially কি হৈছে সববিলাক adsorption site vacant আছে. Initially সববিলাক adsorption site vacant আছে. Adsorption হোৱা নাই. So more adsorption sites are there vacant. So rate of adsorption is more. Rate of adsorption is more. কিন্তু adsorption হোৱাৰ লগে লগে কি হ'ল vacant site কমি গ'ল. Vacant site কমি গ'ল যোৱাৰ লগে লগে কি হ'ব rate of adsorption decreases. Okay, rate of adsorption decreases. Okay, initially rate of adsorption বেছি আছিল, rate of adsorption লাহে লাহে কমি গৈছে. কিয় কমি গৈছে? কাৰণ ইয়াতে vacant site কমি গৈছে. লগে লগে কি হ'ব adsorption বেছি হোৱাৰ লগে লগে কি হ'ব desorptionও বাঢ়ি যাব. As adsorption increases, adsorption যিমানে বেছি হ'ব desorptionও সিমানে বেছি হ'ব. গতিকে এটা কমি গৈছে এটা বাঢ়ি গৈছে. এটা সময়ত কি হ'ব both will be equal. Both will be equal. তাৰমানে rate of adsorption initially what will happen? Rate of adsorption will be equal to rate of desorption. So whenever this condition appears, then we get equilibrium. Initially to equilibrium হোৱাৰ প্ৰশ্নই নাই কাৰণ initially adsorption হৈ আছে. Okay, কিন্তু adsorption হৈ থকাৰ কাৰণে কি হ'ব rate of adsorptionটো কমি যাব আৰু adsorption যিমানে বেছি হ'ব সিমানে desorption rateও বাঢ়ি যাব. Okay, গতিকে after some time what happens? These two become equal. So we get equilibrium. Okay, equilibrium. Okay, so rate of adsorption becomes equal rate of desorption. So we get equilibrium. Okay. Now using these assumptions, a assumption khini loi Langmuir deduced an equation. Using these assumptions, Langmuir deduced an expression. Now, how he deduced the expression, let us see that. Okay. Now, let the fraction of the total surface covered by adsorbate molecules be theta. So theta is the fraction of surface covered. Okay, now we can define theta like this. What is theta? Number of adsorption sites covered by occupied by the gas molecules are number of adsorption sites available. Total kiman adsorption site ase, number of adsorption sites available or number of adsorption sites occupied. That will give us the fraction of surface covered, fraction of the total surface covered. So if this is the fraction of the total surface covered, then surface available for adsorption, surface available for adsorption, that will be equal to 1 minus theta. Okay, because this is the fraction of surface available. This is the fraction of surface available for adsorption. Okay, total surface will be 1. This is the fraction occupied, fraction covered. Okay, and this is the fraction of surface available for adsorption. Okay, now rate of adsorption, that must be proportional to surface available for adsorption. That must be proportional to surface available for adsorption, that is 1 minus theta. Rate of adsorption is proportional to the surface available for adsorption. Surface jimane beshi thakibo himane rate of adsorption o baribo, aru surface jimane komi jabo himane rate of adsorption o decrease hobo. Okay, again rate of adsorption is proportional to rate at which the gas molecules strike the unit surface, of the adsorbent. Okay, adsorbent. So at which the gas molecule strikes. Gas molecule where surface khundi abo, rate at which gas molecule strikes on unit surface 1, because molecule bilake strike kora mane ki there will be change in momentum. Molecule bilake etu surface is surface of molecule bilake khundi aise, molecules are striking at the surface, so there will be change of momentum, and rate of change of momentum is the force. Rate of change of momentum is the force, and force per unit area is the pressure. So this is proportional to this is again proportional to pressure of the gas. But this is nothing but pressure of the gas. This is nothing but pressure of the gas. This is nothing but pressure of the gas. So rate of adsorption. So rate of adsorption is proportional to P into 1 minus theta. Okay, this is nothing but pressure of the gas. This is equal to pressure of the gas. So this is proportional to this. That means this is equal to this. So rate of adsorption is equal to some constant, say K1, P into 1 minus theta. This is rate of adsorption. Okay. Now rate of desorption is proportional to the area covered, area occupied, surface area occupied. So rate of desorption is proportional to theta. Hence rate of desorption is equal to, say, K2 theta. Okay. Now equilibrium exists. Since there is equilibrium, since there is equilibrium, and what is equilibrium? Rate of adsorption equal to rate of desorption. Okay, rate of adsorption equal to rate of desorption. Let me write it like this: rate of adsorption and rate of desorption. Okay, at equilibrium, rate of adsorption must be equal to rate of desorption. That means P K1 P into 1 minus theta, that must be equal to K2 theta, or K1 P minus K1 P theta equal to K2 theta, or K1 P equal to K2 plus K1 P into theta. Hence, theta equal to K1 P K2 plus K1 P. So we are getting this equation. I can divide by K1, I can divide by K2, sorry. I can divide by K2, numerator and denominator. Numerator and denominator I can divide by K2. So what I can do is that K1 by K2 into P, K2 by K2, 1 plus K1 K2 into P. And K1 constant, K2 constant. Okay, what is K1 K2? Say this is the relation gas M, this is surface, this is K1, this is K2 EM. So this is the process, this is gas surface. So we are getting this rate constant forward process, rate constant backward process. So K1 by K2, okay, rate constant forward process, rate constant backward process. So we can say that this is equilibrium constant Kp 1 plus Kp. What is K? K equal to equilibrium constant K1 by K2. Rate constant of the forward process divided by rate constant of the backward process. So we can write this. Okay. So we are getting this equation. Now again let the amount of gas absorbed be Y. So Y is the amount of gas absorbed. Okay. Now that Y must be proportional to fraction of total surface occupied. Total surface occupied. That means Y is proportional to theta. That is, Y is proportional to theta. So Y equal to some constant. Let me write it like this: theta. Ym constant. Okay. So hence theta equal to Y by Ym. Ym is constant. So from this equation, so this is one equation, say this is equation number 1. Now from equation 1 what we get? from equation 1 what we get, we can put the value of theta, that is y equal to kp 1 plus kp, 1 plus kp. Okay, or we can write or we can write y by p equal to kym divided by 1 plus kp, 1 plus kp, or p by y by p by y, that is equal to 1 plus kp by kym. This is equal to 1 by kym plus kp by kym. Hence p by y equal to 1 by kym plus p cancels, so p by ym. So we are getting one equation. And this is known as Langmuir adsorption isotherm. This is known as Langmuir adsorption isotherm. Okay. Now here you see okay, so we are getting this. So this is known as Langmuir adsorption isotherm. So here if we plot p by y, versus p, so we should get a y equal to 1 by mx plus c. So we should get a straight line like this. And from this slope, so this is y dash, this is x dash. So from this slope we get, say, y dash by x dash, we get 1 by ym, because this is nothing but slope. And this is obviously 1 by kym. So we get ym, then we get k also. So both can be calculated. Okay. So from slope, because we can measure these two, so we get slope, so we get ym. Now from this we get this intercept. Okay, so we know ym, so we can find out k. So these two things can be found out. Now we can consider two cases. Say case 1 at low pressure. Okay, at low pressure, so p by ym, when pressure is low, p by ym is low. Okay, this is low. So this is the equation number 2. So from 2 we can find out p by y equal to 1 by kym, because this is small, so we can neglect this portion, so we get this. and this is K constant, Ym constant, so this is constant. This is constant. Okay, this is constant, that means P equal to Y into constant. That means P is proportional to Y, or Y is proportional to P. So what that means? That means at low pressure, that is at low pressure, the amount of gas adsorbed is proportional to pressure of the gas. Amount of gas adsorbed Y is proportional to the pressure of the gas. Now second case we can consider. So at high pressure, now what is then? P by Ym may be very greater than 1 by K Ym. So in that case, from 2 what we get? P by Y equal to P by Ym, and from this we get Y equal to Ym. Okay, that means at high pressure, the amount of gas adsorbed is sufficient to form a unimolecular layer. So these are the two conditions we can consider. So we have discussed about Langmuir adsorption isotherm, and this will be required when we discuss heterogeneous catalysis. So let us stop here today. Next time we will discuss about heterogeneous catalysis. Okay.